Today we're going over CCM8, Unit 2, Lesson 4, Estimating the Value of Irrational Numbers. Some definitions for you. A rational number is any number that can be written as a fraction, positive or negative. Irrational numbers are any number that cannot be written as a fraction, so any non-repeating, non-terminating decimal. This is like pi or the square root of any non-perfect number, non-perfect square. So Vic, number one, very important concept, number one, make a table of perfect squares to help you. So you've got this table on your paper, go ahead and fill it out with all of the perfect squares. I'll give you a second to do that. Just pause the video. Once you've done that, now we're going to go through and actually simplify these non-perfect square roots. So when we start simplifying, we have to ask ourselves, okay, we've got the square root of 32. What times what gives me 32? I want to pick one of these numbers, one of these perfect squares, and I want to say, is 32 divisible by any one of these? Is it divisible by 4? Well, yes it is. But if it's divisible by 4, 4 times what? 4 times 8 makes 32? Well, 8 is also divisible by 4. And what we're trying to do is we're trying to take out or pull out any perfect square that we can and get it out of the radical sign. And that's how we simplify. So it's divisible by 4, but it's also divisible by 16. And I'm going to take the greatest perfect square that I can, and I'm going to pull it out. So this is how I'm going to write it. I'm showing my work here. The square root of 32 is made up of the square root of 16 times 2. 16 times 2 is 32. So what I'm going to do is I'm going to literally take the square root of 16 and get 4. So I've simplified this portion of my problem. What's remaining is the square root of 2. I can't simplify that any further. So this is actually the simplest form of this radical. And that's what we're doing today. So let's try number 2, 18. Look up at your chart and think, what perfect square down here goes into 18? 9. Okay, 9 times what? 9 times 2 gives you 18. Well, I can take the square root of 9, which is 3, and what's left? The square root of 2, and we're done. Why don't you try these two down here? Why don't you just pause the video, try them yourself, and then when you're done, hit play, and the answers will be here on the screen. Did you get 2 times the square root of 5 and 5 times the square root of 3? I hope so. Here's a way you can check yourself. In your calculator, you can type in square root of 20, enter, and leave that long decimal on your screen. Then hit 2 times the square root of 5 and hit enter, and compare the two answers you get. This answer in decimal form and this answer in decimal form on your calculator should be exactly the same. That's how you know you did these right. Why don't you do these last 3 examples, try them out, hit pause on the video, and then when you're done, hit play, and you'll see the answers on the screen. For number 5, did you get 2 times the square root of 14? Number 6, 2 times the square root of 10. And number 7, 3 times the square root of 11. Well, I hope you did well.